Good evening, my name is Washroom Edward. As a follow-up to my previous video on Arima modeling, I'll be actually teaching how to identify an Arima model and to estimate an Arima model. So the first thing to be done is to check the stationarity condition of the time series data we actually intend to use for today's practical class. We are going to rely on the Human Development Index today. We are going to look at the annual time series data of Human Development Index in Nigeria from 1981 to 2021. So we are going to look at 41 years observation, though it's low, because in the Arima modeling system you are expected to use a high frequency observation, though this is lower frequency, but for practical purpose let's allow it to go. So basically the first thing to do is to check, to test the stationarity condition of the time series data. So looking at this information, the first thing to do is to go to view. From view you go to the unit to test. I'm using the augmented Kifula unit to test to check the stationarity condition of the data. My automatic selection is the SWAS information criterion. I'll leave it at level. I'll select trend and intersect. I click OK. So this is my level results. Human Development Index. The T statistics is lower than the critical value at 5%, and the p value is above 5%. So we conclude that there is a unit tooth problem in this result. And given the presence of unit tooth problem in this result, the first thing to be done is to subject it to first differencing to detrend the data, enable us to have a data that will be clean for what we want to do. To actually go to first differencing, you will move on to view. From view we go to unit truth again. From unit truth text you go to first difference. We hit the OK button. So this HDI component has been detrended, and we now have a series that is stationary after first differencing. To check what I have just done using the correlogram, you go to view, you go to the correlogram statistics, you hit on it, you leave it at level, you click the OK button, you'll be exposed to a result that looks like this. And in this result we actually have a scenario that looks similar to what we actually had been exposed to previously in the augmented Kifula results. We have this statistical, we have this AC, PAC, Q statistics and P value. The autocorrelation section represents the moving average section. The partial autocorrelation section represents the ARO section. And the rules is that the spikes you are seeing in the moving average section is not expected to cross these dotted lines. And the fact that these spikes are crossing these dotted lines implies that there is a unit tooth problem with this result. And also the partial correlation, which is the autocorrelation box, the first spice crosses the dotted line, which shows an evidence of a unit tooth problem. Secondly, using the junk box statistics, the probability value at this area, whenever time the p values are statistically significant, less than 5%, we then conclude that there is a unit tooth problem in this Human Development Index series using the correlogram statistics. And the next thing to do is to move on to first differencing to see how we can detrend this Human Development Index series in line with what we did in the ADF. To achieve that, we go to view, we go back to the correlogram statistics, we move from the level statistics to first difference, we hit the OK button, we'll be exposed to a result that looks like this. From this result we can now select identify our Arima model. We look at this results. The unity problem has been resolved because the the p values are now above 5%. The the 8C column, which is the auto-regressive, that is the auto-regressive column, is now better than how it was before. The moving average column is also better than how it was before. If you look at the spikes, none of the spikes crosses the dotted line in the moving average column. None of the spikes also crosses the dotted line in the autoregressive column. Then for we to identify the best Arima model from this integrated series, because it's only when your series is integrated that you can be able to identify your Arima model. And your Arima model will be identified in the correlation second first difference results. So from this result now we can now select or fit our Arima model, select, identify the best Arima model. Just like what my mentor Ngozi Adeleye used to say, Arima system is more of an art but not a science, implying that the fact that I actually will be selecting a set of Arima model today doesn't mean that that will be the best. Some other person can also use the same data set, identify better Arima models in the system. So identification of the best model is where we are now. So to proceed with that, we have the ARO column and the MA column. We actually have the spikes, and given that these spikes are not much noticeable in most areas, and in most of this area this spikes decays exponentially, and in most of this area it doesn't decay but it doesn't have a particular pattern. And given the fact that it doesn't have a particular pattern, it also means that the value of the PAC do not also have a particular pattern, and the value of the AC do not also have a particular pattern. So to identify the Arima model, we can decide to say we have Arima 1 model. We can say we have Arima 1 the first model. We can also say we have Arima 1 Arima 2. We can also identify Arima 3 1 Arima 3 1. We can also identify Arima 3 1 2, Arima 3 1 2, and these are the three Arimas I want to identify. We also have some others here, but let's just make do with this. We have identified 4 Arima model: Arima 1 Arima 2 1, Arima 3 1, and Arima 3 1 2. In our next video on diagnostics and forecasting, we are going to be estimating. In our next video we are going to forecast and diagnose most of these Arimas so identified. So the next thing to be done is to estimate these Arimas and present their results for our next video. So to have that done, we need to proceed to quick from this result. We move on to quick up here. You go to estimate equation. In this equation specification box, you specify your Arima. Recall that your dependent variable is human development index. So we now say the difference of HDI. We give a space, we give constants. We now say AR1 MA1. That is the first model we are estimating. Without changing any other thing, we hit the OK button. This is our first Arima 1 estimated this day. So the first thing we'll do is to save this model as Arima 1 name. We'll now say 1 saved or minimize this results. Move on to quick again. You go to estimate equation estimation box. The difference of human development index, the constants AR 2 MA 2 AR2 MA2. You hit the OK button. We'll now expose to another result. I will name this result 222. Sorry, 212. I hit the OK button. I will name this result Arima 212. I hit the OK button. Okay, let me just say equation 2. If that be the case, I have to rename my first equation. This equation must be renamed. I have to rename my first equation. This is my first equation. I have to rename my first equation to equation 01. Okay, if that is the case, I will now go back to quick. From quick, I move to estimate equation. I will estimate my test Arima model, the difference of human development index, followed by a space and a C, and I will now specify AR3 MA1. I hit the OK button. Then my third equation, I'll go to name and name it equation 3. I will click OK. I'll close it. Then I'll go back to quick again. I will go to equation estimation box. The difference of HDI. Followed by a constant and a C, or a C rather. AR3 MA2. I'll close it up. I hit the OK button. I will not be exposed to this other equation again. I can now say this equation 4. I hit the OK button. So I have 4 tentative models, 4 tentative equations. In my next video, I will present the diagnostics, where I will present this whole equation and actually take decision on them. Thank you for staying tuned to my channel, and God bless you.